Introduction. Exactly that. You know, that golden telescope we humans built is taking some mind-blowing pictures of space right now. Well, it turns out it's so powerful it might have just shattered our understanding of the universe. It is difficult enough to imagine a time roughly 13.7 billion years ago when the entire universe existed as a singularity. According to the Big Bang Theory, one of the main contenders vying to explain how the universe came to be, all the matter in the cosmos, all of space itself, existed in a form smaller than an atomic particle. Once you think about that, an even more difficult question arises. What existed just before the Big Bang occurred? For years, researchers have made a series of speculations, but there is no evidence to prove that something is true or false. Now, for the first time, the James Webb Space Telescope has peered into the distant past of the universe, giving us an unexpected discovery. It presents major challenges to our understanding of the cosmos. What was there before the Big Bang? And what is it that the Webb telescope has uncovered that has shocked everyone? Historical and scientific context. The question of what existed before the Big Bang itself predates modern cosmology by at least 1,600 years. 4th-century theologians such as St. Augustine wrestled with the question of what existed before God created the universe. His conclusion was that the biblical phrase "in the beginning" implied that God had made nothing previously. Moreover, Augustine argued that the world was not made by God at a certain time, but that time in the universe had been created simultaneously. In the early 20th century, Albert Einstein came to a very similar conclusion with his theory of general relativity. Just consider the effect of mass on time. A planet's hefty mass warps time, making time run a tiny bit slower for a human on Earth's surface than for a satellite in orbit. The difference is too small to notice, but time even runs more slowly for someone standing next to a large boulder than it does for a person standing alone in a field. Based on Einstein's work, Belgian cosmologist Reverend Georges Lemaitre published a paper in 1927 proposing that the universe started out as a singularity and that the Big Bang led to its expansion. According to Einstein's theory of relativity, time only came into being as that primordial singularity expanded toward its current size and shape. Case closed? Far from it. This is one cosmological quandary that won't stay dead. In the decades following Einstein's death, the advent of quantum physics and a host of new theories resurrected questions about the pre-Big Bang universe. Speculative theories. Here's a thought. What if our universe is but the offspring of another, older universe? Some astrophysicists speculate that this inflation theory story is written in the relic radiation left over from the Big Bang, the cosmic microwave background, CMB. Astronomers first observed the CMB in 1965, and it quickly created problems for the Big Bang theory, problems that were subsequently addressed for a while in 1981 with the inflation theory. This theory entails an extremely rapid expansion of the universe in the first few moments of its existence. It also accounts for temperature and density fluctuations in the CMB but dictates that those fluctuations should be uniform. That's not the case. Recent mapping efforts actually suggest that the universe is lopsided, with more fluctuations in some areas than in others. Some cosmologists see this observation as supporting evidence that our universe bubbled off from a parent universe. In the words of California Institute of Technology researcher Adrian Yeck, in chaotic inflation theory, this concept goes even deeper. An endless progression of inflationary bubbles, each becoming a universe, and each of these birthing even more inflationary bubbles in an immeasurable multiverse. Alternate models and theories. Other models revolve around the formation of the pre-Big Bang singularity itself. If you think of black holes as cosmic trash compactors, they stand as prime candidates for all that primordial compression. So, our expanding universe could theoretically be the white hole output from a black hole in another universe. A white hole is a hypothetical body that acts in the opposite manner of a black hole, giving off serious energy and matter rather than sucking it in. Think of it as a cosmic exhaust valve. Some scientists propose that our universe may have been born inside a black hole and that every black hole in our universe could contain separate universes as well. But some scientists think the universe started not with a Big Bang but with a big bounce. Long ago, medieval religious philosophers in India taught that the universe goes through an endless cycle of creation and destruction, evolving from an undifferentiated mass to the complex reality that we see around us before destroying itself and starting anew. Some contemporary scientists have arrived at an idea with striking parallels. They believe that instead of a Big Bang, the universe expands and contracts in a cycle, bouncing back each time it shrinks to a certain size. In the Big Bounce theory, each cycle would begin with a small, smooth universe, not as tiny as the singularity, that gradually expands, becomes clumpier and more warped, then collapses and smooths itself out as it shrinks to the starting size. The cycle would begin again. New insights from the James Webb Telescope. For the Big Bounce idea to work, it must bypass the singularity theorems developed by British physicists Roger Penrose and Stephen Hawking. These suggest that a contracting universe would shrink to a singularity, like a dying star condenses to form a black hole. Big Bounce models rely on negative energy counteracting gravity, reversing the collapse and driving the universe apart again and again. In today's world, this is where the James Webb Space Telescope comes in. With its advanced capability, Webb can look further back in time than Hubble, detecting infrared wavelengths that pierce through the dense smog of light and dust. Webb has already revealed unprecedented details about the early universe, such as the star cluster NGC 346 in the Small Magellanic Cloud, located 200,000 light-years away. This region offers insights into the star formation conditions during the universe's cosmic noon. The telescope's observations have detected protostars lighter than our Sun, revealing details about star formation and potentially planet formation in an environment similar to the early universe.